So I came here to talk about cognitive APIs and then give you a couple examples of what you can do with them. And without further ado, let me just keep going. Let me do this one. Yeah. All right. So about maybe 2-3 years ago, depends on when we start looking, big companies like Microsoft, IBM, Google, and lately Amazon started releasing a set of new kind of services that have not been available before. They gave them different names. Microsoft called theirs cognitive services. IBM labeled it Watson, which is really a good marketing name, by the way. Google was very pragmatic, just called them machine learning APIs, because that's what they actually are. They all kind of the same thing underneath. Amazon didn't even group theirs into a category. They just released services that do similar things that the other guys do. They can do voice to text. They can do computer vision tasks. They can do natural language processing. And I'll show you a couple examples of types of these APIs today. You'll see the pre-trained models, which is when a vendor not only built data pipeline, not only came up with an algorithms instead of what machine learning types of algorithms, it also came with their own data. And they trained the models, which makes that model kind of generically useful for many different use cases. And then you can use it by just supplying your data point and get the prediction or get the answer from it. You'll see the ones that you can train, which means, again, the vendor gave you the pipeline, gave you the algorithms. You supply your test data. It's all supervised learning anyway. You train your own model, which will be specific then to whatever business you're dealing with, and then you use it as an API. And some of them come with an active learning component, which is the more you use the API, it can collect the data you sent through, kind of record as a training data, and then you can retrain it, which hopefully, if you do it right, will make the endpoint better and better at what it does. Now, the best way to show you would be to do a live demo, and I wanted to go and try again what happened with my internet and why I didn't have it, because I had it just now all day and all that good stuff. So let's see. All right, we're online. Yeah, we are. So what I'm going to do, I'm going to send, this is computer vision models, 4 different APIs from Microsoft, IBM, Google, and Clarify. It's a little competition. We'll send a couple images down to those APIs to see what they will see in the image. I will then show you how I built it, how it felt as a developer to use these APIs, how similar or different they are, and I hope it's going to be a little fun. So first thing first, we'll have this rock climber, and let's see what the APIs will see in it. In all real time, if you want to do it, you can do it. It's all runs on Heroku. You see the URL up there. And what I want you guys to look at is at how specific the tagging came back, right? I mean, some of them just saw the climbing activity. Some saw a rock climbing or even a sports climbing, which is a lot more specific to what that lady is doing up on the wall. But now, read this description, which is generated by Microsoft. The only endpoint that actually gives me descriptions. I know Google does it. I know Facebook does it. They don't give me an API to use it. Microsoft does. And I have lots of fun sending different images down to it. And by the way, do not try writing skis on top of a stone wall. I would not do it for sure. Now, let's do something else. Let's do this one. Nice car. Same thing. First thing, we're going to look at the specificity of the kind of tags that you can get back to. And by the way, this type of functionality is right now built into many modern digital asset management systems. But again, you can only get as good of a tagging, as good of a training data you supply, right? Whether it's just a car or maybe a supercar. And again, same thing. I do like that, an API saw a motorcycle on top of a car, which wasn't there. Now, before I get back to my slides, I did want to show you how, like on the receiving end, before I show you the calling end, the API into the service, the results look very much the same. This is the raw JSON that's coming back from the endpoint, and the tagging, and then the confidence in that tag being present will be very similar in the same, different format. I get it, but it's the same type of data. Now, if I try a face, and I'll explain why, and this is myself a couple of years ago, some of them will still only give me tags. Google API, however, will give me lots of facial features. Now, I'll argue, I didn't try measuring. You see, there's a left eye and there's a right eye. with coordinates. If you remember the image back, I will show you again. I only see one eye. It did see two. Now, I didn't try. Maybe it actually pointed me at the right place physically on my head, but that's just, Anyway, so enough for the first demo. Let me go back here, and I want to keep talking about, now, as a developer, right? How did it feel for me to use them? Now, this demo is absolutely 100% in the browser. There's no server side. It's all JavaScript. And I intentionally went for raw endpoint. Like, I didn't use any SDKs provided by the vendors because I wanted to see, hey, how it feels to just, reuse it on the bare metal. And yes, I may be sending my data in a different way because of how the API expects it to come. I may be authenticating in a different way, but it feels very much the same. It's the same easy single HTTP call to an endpoint with, hey, this is my image, give me back what you see in it, and then you're going to get back a JSON file. And I was comparing Microsoft versus Clarify, but they're all give me very similar feel to the API. Now, it's a little distorted, but you guys can read it, okay? All right. Now, the API design, though, may be different. Almost all of them will give you individual endpoints for different computer vision tasks, like tagging versus description versus face annotations, right? Google gives you one single endpoint for all the computer vision that it does. And the way they've designed it is by making their payload, you actually say, hey, this is the image, and I want you to do these things to it. Now, but don't think that they will not meter you for individual things. Like with Microsoft and the others, you'll have to pay for individual use of the different endpoints. Google will do the same. They'll charge you for what features you've used, even though it's a single HTTP call, right? But it's a different API design. I like it. It gives me, I know they'll keep it as they're going to add features. I can start consuming the new features by just adding more feature requests, and it'll just extend the, the result. Like that face annotations you saw in the image with the face, if it wasn't face in it, it wouldn't send me. All right, that's at the beginning. You got a good feel of the, those APIs. So next thing what I want to do, I wanted to show you what I call a smart app, and I thought that the good way to show it would be to, come with a very, right now, modern, people like it, chatbot. And what I have, and what I'm going to show you before I explain how it works, is a, let me do again, I have to switch back to my desktop. So what we're looking at, and I'll make it large enough, it's all real. I'm not going to open my messages. This is a e-commerce, e-store that sells bicycles and accessories. I'm using the AdventureWorks SQL Server database, so you guys may know what it is. It's ERP example with lots of product data and usage data. And I'm going to ask them, what do you guys have? Which is like, you talk to an associate in the store, and they'll tell you what they've got. And they've got, let's see. Come on. Come back. Yep, they have components, bike, accessories, and clothing. What kind of components will be my next question. And we'll see. They have frames, forks, wheels. Show me wheels, please. Oh. There's a spell check on the way in, so it should be fine with me misspelling stuff. So now I get some products. Let me look at this wheel. I'll explain you what happens behind the scenes in just 2 minutes. Let me add this to the shopping cart. And then it actually has some recommendations for me. So let me see what those are. And there are some products that people frequently buy together. Apparently, they all buy wheels, which is actually real data that the AdventureWorks supply. But I think I'm done, so what's in my cart now? I could look at bikes, but I just want to spare you guys from looking at me chatting with this store. Yep, I am. And I should be all set. And now the bot even smiles at me and probably will drink some beer with me, right? All right. That's good. So let's go and look at what actually was it. Like, what is behind it, how it works, how am I using the APIs. But first, behind the bot is lots of different APIs put together. So at the center is a commerce engine, and I'm using one of the young startups from UK. They do API first, kind of cloud first commerce. Azure Search for all the product lookups. Microsoft Recommendation API, which is, by the way, train your own cognitive service. I had to supply my data. It then ran algorithms to build the frequently bought together model that I can now use to get out recommendations from it. Like I didn't build anything other than train their model. I'm using LUIS, which is another cognitive service. It's another train your own language understanding intelligence for understanding what the user is saying, so I can then execute or fulfill their intent. The example I usually give is that you ask a bot to, hey, schedule me a meeting for tomorrow at 2 p.m. The intent to get on your calendar is clear, but you can't fulfill it without extracting tomorrow at 2 p.m. So it does two things. It does intent detection and entity extraction, right? I'll show you. It's all wired together with the Microsoft Bot framework for the actual conversation, connection to Skype, connection to the web chat, and a couple other channels. I've then added the spell check, which apparently is another cognitive service. You don't even have to train it. It's trained, it's fully available for different languages, not all of them, but English and a couple others. I don't have to use it. LUIS will directly call it for me before it tries to understand what the user typed. Will then reason over corrected sentence. I don't have to get the Azure key and pay for it. That's as simple as it gets. Now, I added text analytics service, which is another pre-trained, based on different languages, service. What I do with text analytics, I do sentiment detection. For a simple yes/no question, I can type like, yeah, totally, let's do it. I'll get a positive sentiment, even though it's not a yes, and say, okay, that was a yes. And be better, be smarter by using a service that detects just positive versus negative statement. And I also added API.ai for languages that LUIS doesn't support, but that's kind of beyond today's. So let me show you how it works. Like I said, it is intent-driven, which means it's not hard-coded. It's not, not trying to go by a specific sentence or whatever. It tries to detect what the user wants and then runs a specific dialogue. The way I understand this is I'm using some of the actual good old programming, some regexp and string matching for some things like smiles, I'll show you, commands that I'm sending to the bot. But the main work is done by the LUIS endpoint. And the way bot framework does it, I have to just configure the recognizer without having to call it directly. But if I did call it directly, it would be also a single HTTP call. Here, this is my sentence. Give me back the intent and entities you've recognized, because I have pre-trained it already. So let me walk you through. You remember how I conversed with the bot? I said, hey, what do you guys have? So let's take that. Let's type it into an interactive testing. This is a LUIS web-based training of my model, but I can also test it. LUIS will detect in that sentence the show top categories intent. That's how I trained it. This thing maps to a dialog categories, which then really just runs my code. And there's nothing, no magic in there. I run the search for categories. I present it back to the user. All right, let's keep going. We ask about components. Let's do the same thing. Let's type that sentence into the interactive testing. This time, however, remember I told you about the entity extraction part? The LUIS detected that there was an entity in that sentence, because to fulfill that intent, it needs to search for components. And then it's the explore intent. Next thing I asked, and I got the answer with the categories and whatnot. Next thing I asked was, show me the wheels, please. Which is, again, let's do the same thing. Type it into the interactive testing, get the entity extraction part, get the same explore intent. In response, that time, however, I got the product list, right? So question, I'll give you the answer, it's not the question to you, but how the bot, given same intent, right? It's same intent, it's all the same, gave me two completely different answers. And not surprisingly, that's how I wrote the fulfillment of the intent, right? So when I know that you want to explore, I'll run parallel search for categories and products. And based on what comes back better, I'll either give you one or I'll give you something else, right? So it's not the language understanding, the machine learning stopped at, okay, you want to explore the catalog, you're searching for X. I then write code to search for X, and then based on what I find, I'll give you either a list of subcategories or specific products. All right, so next thing was this. We'll look through products. I clicked on the button, which sent the command, this time, specifically to my backend bot service. Because, I don't really have to type anything more complex. I don't expect them to be able to ask for specific product by ID. So I have a command recognizer, just a regex to detect these guys. And by the way, some channels will not show you the command, which is just, it should be a silent postback ideally. If I ran the web demo, which is a little, I like my Skype because it gives you better visuals than the web. Clicking that button does not display the command because their web iframe and the React app that they built for the web chat actually hides it. It doesn't show you the message. But in reality, that's the only interface my bot has, right? It only receives messages. It's got to be there. It just doesn't show it. Same with this kind of carousel. You guys saw me scroll through carousel of products when I look for recommendations. Some channels will not show you the carousel because they're not capable of displaying it. But really what I wanted to talk about here was not the actual carousel, but the recommendations themselves. So how did I get them? As a developer, again, yes, I've trained the recommendation model because I supplied my data following documentation. Using it, though, was as simple as what I showed you before with computer vision and language understanding. I'm making a single HTTP REST call to an endpoint. I authenticate myself and I say, hey, this is my model. This is the products that I'm looking at. Give me 3 results at most. And don't give me anything that's below 50% confidence that people do buy them together. And that's as simple as that is. I get back JSON that I can present the way I like it presented. It's really, really simple. And then the smiling part, that's no magic. They're just regex. There are different ways, different channels will send you the smiles. Like Skype will do this SS markup or this regular smile. And you can then, again, write a fulfillment of the intent to respond back with the smile. So you guys kind of like that, but it's really simple as far as how do you do that. It just, it's nothing fancy. But anyway, we're going to get to the takeaways. It's only 4. 1, cognitive APIs are very simple and very easy to use. I was surprised when I get to work with them. And we built more advanced things with them than what I'm showing you. But you should totally expect a single call into the model. If it's trained and kind of available like a computer vision, boom, just call it and you get the response back. If you train something either through their UIs or a sequence of API calls, because you can train them programmatically too, the trained model will be as easy to use, just one call. Whatever parameters you supply, you get back the JSON you can use. As I showed you, the actual smart part is still yours to design and build, right? Those APIs will help you get there, but you still program, which I like a lot. And we're going to be here. We're going to still be doing this for a little bit. Nobody takes that away from us yet, not yet. Now, more serious though, I showed you this chatbot. Whether you believe in them or not, whether they will become the new mobile apps or not, it's not, not the question. But to be enabled on these channels, to do something useful with them, your backend, whatever you have, products, enterprise, right, has to be API enabled. My bot is a web. It runs in Azure. All it can do is call other APIs. It'll happily consume Microsoft's, Google's, and everybody else's machine learning endpoint. But what about the actual functionality? I've used the cloud-based API-first e-commerce engine. What if I had to go back to whatever my enterprise runs behind the firewall? Can I do it? Probably not unless it's API enabled. I do talk a lot to our clients, and I tell them this, that, hey, guys, if you don't have these APIs, and whatever you guys, how you manage them, how you secure them is a different question. But not having them is probably not an option in 2017. And last but not least, smile. Makes your day better, for sure. That's it. You guys can find me on Twitter, and I also am Pavel Veller at GitHub. This chatbot, with all the code, all of it is on GitHub. There's a video that I've recorded on YouTube that actually does explain some of what I just showed you, so you can replay that if you don't like the recording of this. And I do write recently mostly about building bots, but there'll be something else when I'll be interested in something else. So please follow me. That's it. Thank you. Any questions? Yes.
Yes. So you talked a few times about. You talked a few times about training the bot. So what, with the context of recommender engine,
yes,
that could be pretty straightforward. But with the context of actual chats, where did you get the data, and how well did you find that actually working in practice?
A great question. So I didn't really train the bot. With the bot framework that I've used, you program So as you see, I showed you the fulfillment of those intents. That's all programming. I've trained the language understanding service, which means I build a dialogue. So I sit down. Okay, let me make a step back. And this is what I'm writing an article. It's going to be on the blog, by the way, probably when I get back home, because I finished on the plane, about some of this. But if you want to build a bot, or a client, my client wants to build a bot, I ask them, hey guys, can you sit down and write a conversation with the bot as if it existed? Just tell me how you want to converse with them. I'll see the patterns. I'll ask them to then, hey, can you guys give me 10, 15, 20 sentences, examples of expressing that thing in a different way? Because I'll need to train my language service to understand that same thing said in different fashions, right? I have to give it enough examples. It's all statistical models. It's all machine learning. It's got to have enough examples, build those word-to-vec, whatever they're using, different algorithms to then be able to recognize it, right? So I came up with myself, because it was all kind of playing with it. And by the way, if you go to the GitHub, there's a Lewis model in JSON. If you download it, you'll see all the utterances that I've trained it on. So I've used like 15, 20, 25 different ways of expressing same thing. For entity extraction, there is a technique when you kind of, in the same sentence, can have, let's say, like, hey, show me components, show me bikes, show me this. And those names are specific products from a category. I can extract them, and I can build a list, which will specifically be understood that, hey, those things are all the same. If you see one of them, you'll see all of them. It's not, it's actually surprisingly easy. For the simple things like this, it's a kind of commoditized AI. It's not it's not really a conversation engine. It's a very transactional interaction. Like, don't get me wrong. It's really just, it can only do these things.
So the API that does sentiment analysis is not actual NLP. This is really just transactions.
No, theirs is theirs models are NLP models. I train them on sample utterances. I haven't built any of the string matching myself. What they do is, let me take it back. What they do is black box for me. Whatever Lewis does to recognize the intents, I don't really know. They can do string matching, but they probably can't, because I can supply them arbitrary sentences. All they know is that it's English or Russian. I have to tell them the language, because they're going to use probably word-to-vec or similar models, which are language specific. But
have you tried this on the non-Windows platform?
So the bot, there's nothing Windows. It runs in Azure,
Okay.
but it's a Node.js app. So the bot itself is Node.js app.
Okay. So
The reason I run it in Azure, I like their app service. It gives me the same as Heroku experience by git push. That's my deployment workflow. I git push. It has a hook into my branch, whatever master develop. It'll deploy automatically as I push. Love it. But then I still need all the Azure keys for all the other services. So I figured not to have to deal with, hey, this is on Heroku, this is in Azure, this is this, just everything is in Azure. But there's nothing Windows specific on it.
Okay.
If that answers the question.
Does it remember context of like multiple conversations? Like, you ask category then subcategory?
Unless you make it remember, it won't.
Okay.
So that's a short answer. But you can make it remember if you want to. You can store it anyway. Like, you see all the messages as the bot developer, right? You can do it.
Okay.
But they will not, and they make a point of not doing it, because otherwise, people wouldn't build on their platform.
Okay. Thanks.
Thank you, guys. Yeah, go ahead.
So,
They all have free tiers, but they're only going to give you, like, let's say if you have an Azure subscription, you'll only be able to have one text analytics free. If you want another one, you have to go to whatever plan they start charging you for, but they also threshold them. Like text analytics gives you like 10 per second, and maybe you can go call them and have a special something set up for you, but in public Azure, you'll be throttled. You'll get whatever, 4 something, denial of service. You're not going to get. So you can't really overwhelm them, but it's definitely, so if you build something more real, you'll probably likely roll your own NLP, and there are lots of tools to do so because of those reasons.